So today's lecture is over 1.3 truth tables, so if this lecture is a little long and I do quite a bit of examples in here, so if you have to chunk it up in, 5 minutes here, 10 minutes here, just, keep in mind that might be a good option. So we're going to talk about truth tables, and we're going to do some examples of truth tables, and we want to focus on the objectives of constructing a truth table for a compound statement. Determine whether two statements are equivalent. So to do that, we're going to look at their truth tables, and then we're going to apply De Morgan's laws to find a negation of a compound statement. So a truth value is simply as true or false. The statement can be either true or the statement can be false depending on the situations given. So a truth table is a listing of all possible combination of individual statements as true and false depending on the individual makeup of the statement. So if I say something like P and Q, or P or Q, the trueness of that is going to reflect on the trueness of P and the trueness of Q. And I think that some examples will help on that. So the negation of a statement. Your PowerPoint used the example P is it's snowing. So the negation of that would be it is not snowing. So this little tilde is just putting the not in front of it. So for a truth table, we're flipping the truth of P. So here P is either true or false. So not P, if P is true, then not P is false. And if P is false, then not P is true. So the example, it's snowing. If it's snowing is true, then it is not snowing is false. It's the opposite of it, the negation of it. If it is snowing is false, then it is not snowing is true. It either has to be snowing or not snowing. So you'll have to fill in columns given a column of P, and eventually these will get more complicated. So let's look at a conjunction. A conjunction is combining two things with the word and. And it turns out for a conjunction to be true, the components P and Q must both be true. So if I had the statement about eating ice cream and cake, I have to both have eaten ice cream and cake. If I didn't eat ice cream, the statement eating ice cream and cake would be false. So from the truth table here, you'll be given P and Q. So this will be given. And these will be what you need to fill in on WebAssign. So these will be your answers. So P and Q, well, P is true, Q is true, so your answer, P and Q, would be true. P is true, Q is false, so P and Q would be false. And the same thing, false, true, so P and Q would be false, and false, false would be P and Q would be false. So we'll do a little bit more complicated ones later on, but for this one, for P and Q to be true, both P and Q have to be true, and that only happens in the first instance. The disjunction of a statement is combining two statements with the word or. In this case, both components have to be false for it to be false. So it's only false when both components are false. As long as one of them's true, then the disjunction P or Q is true. So here, true, true, true. True, false, that's still true because there's one true. False, true is true, but false, false is false. So this is only false when both P and Q are false. So let's look at an example that might come up in your homework. You'll be given P and you'll be given Q, and you'll be asked to complete the rest of the table. So let's look at not P. So for not P, I look at the P column. I look at the P column, and for the first one, if P is true, then not P is false. This P is true, so this not P is false. This P is false, so this would be true, and this would be true, because this P is false, so the not P is true. So now I'm going to look at combining Q and not P. So I combine these two with the word and. So remember the word and, they both have to be true. So true, false, so this is false. False, false, so this is false. True, true, so that the statement Q and not P is true, and then false, false, that ends up being false. So the statement Q and not P is only true when Q and not P are true. And then looking at the next one, I'm comparing Q with the statement Q and not P. So I take Q and not P, and now it almost helps to put your fingers on the screen and keep them under those columns so that you know for this one, you're talking about this column and this column joined together with the word or. So or means they both have to be false for the statement or the expression to be false. So here I'm looking at true, false. So or means that's going to be true. Here I have false, false, so that tells me false. Here I have true, true, so that's true, and I have false, false, so that's false. So this is a completed truth table there. Sorry if my F's look like E's. So that simplifies the conditional and conjunction and disjunction. The next thing we're going to talk about is the conditional. So your PowerPoint goes to this example. You give me $50 and I'll give you a ticket to the ballet. So we can view this P as a promise. So I'm saying, I promise if you give me $50, I'll give you a ticket to the ballet. So we have two options. So either I give you a ticket to the ballet or I don't. You either give me $50 or you don't. So down here, if I promise to give you $50, or sorry, you promised to give me $50 and you gave me $50, that's true, and I promised to give you a ticket to the ballet and I gave you a ticket to the ballet, that's true. The conditional is true. If you give me $50 and I don't give you a ticket to the ballet, so then the case here that Q is false, then the conditional is false. But what happens if you don't give me $50 and I still give you a ticket to the ballet? Or you don't give me $50 and I don't give you a ticket to the ballet? In this instance, the outcome is still true, that the promise still holds that if you did give me $50, I would still give you a ticket to the ballet. So it's important to note here that this is going to turn out to be true and this is going to turn out to be true. So in any time that the conditional is false, so when you have P implies Q, when P is false, P implies Q is always true. So it does not matter what Q is always true. So that's something to keep in mind with conditionals. That if P is false, so here you can see that P is false here and P is false here, then the conditional is still true. It does not matter what Q is. Eventually, we're going to use truth tables to verify an expression is equivalent. So your PowerPoint has, it is not the case that the car is not new. Well, that's a negation of a negation, and a negation of a negation is the same thing as saying P. So if I said, it is not the case that it's not snowing, you could make the conclusion that it's snowing. So if I make a negation of a negation truth table, so I have P is true or false, not P is false or true, and P would be not P would be the negation of not P, which is true or false. You see that this column, and this column are exactly the same, And it happens to be whenever columns are identical, the expressions are said to be equivalent. And then they can use interchangeably. So if you have a truth table, if you know that two columns are the exact same, you can say that the expressions are equivalent. So P is equivalent to not P. It should make sense. So there's a question in your book. One of the examples is to define, are the statements, if I'm a homeowner, then I do not pay property taxes, and I'm a homeowner and I do not pay property taxes, are they equivalent? So one way to test equivalency is to put them into a truth table and verify that the columns are the same. So we have the statement P and Q, not P, P and not Q, and then P implies Q. Because here, if I'm a homeowner, then I pay property taxes. That's the conditional if P then Q. And I am a homeowner and I do not pay property taxes would be represented here. So this would be 2 and this would be 1. So this statement 1 and this statement 2. And we're going to see if they're equivalent. So not Q would be everywhere I have a true or false on Q, I switch it. So here I have a true, so this ends up being false, true, false, true. So now I'm looking at P and not Q. So I'm looking at these two columns, and I'm joining them with the word and. So and tells me they both have to be true. So this is false, this is false. This would be, sorry, ignore what I just said there. I'm going to go back to, and it's very important that you notice that you use the right column. So P and not Q. So this column P and this column not Q. So I'm using them with the word and, so they both have to be true for it to be true. True, false, so this is false. True, true, so this is true. False, false is false. And false, true would be false. Now, I look at P implies Q. So P and Q. So now I'm looking at these two columns to do my answer here. So true, true would be true. True, false would be false. False, false would be, here I have a false in my conditional, so my conditional is automatically true. This false is in my premise of my conditional is automatically true. It does not matter what Q is. I can make the conclusion based on the premise is not held. So the premise is not held up doesn't mean the conditional is false. Just doesn't mean that it has had an option, has had a chance to be false. So if I say, if you give me $50, I'll give you a ticket to the ball. If you don't give me $50, then you never know if I would give you a ticket to the ball or not. So you have to assume it's going to be true if you did give me $50. So now we're looking at comparing the two statements. So automatically we can see that the columns are not the same. So everywhere I have a T, I have an F. Right? F, 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 T, F, F. This is T, F, T, T. So it turns out that they're not equivalent. They're not equivalent, but it turns out that they are negations of each other. So they are negations of each other. So if I want to negate P and not Q, that is going to be equivalent to saying P implies Q. And another thing of this, if I negate P implies Q, this is equivalent to P and not Q. So this is the one I want to focus on, negation of a conditional. So when you negate a conditional, you never change the sign here. So if I distribute this negative, I do not distribute it to my premise. So if I'm negating a conditional, if P then Q, that is the same thing as saying P and not Q. So that's one of the negations that's going to come up in your homework. If I say not, or the negation of the conditional P implies Q, that's equivalent to a conjunction of P and not Q. So this negation, when you have a conditional here, right? So we're talking about the conditional. If I negate the conditional, I switch it to an and I negate the conclusion of the conditional. So an example, before I get into De Morgan's laws, let's look at an example. If I want to take the negation of P implies not Q, that is going to be equivalent to saying P and not Q. So I'd say just P and Q. Another example, if I said the negation of not P implies Q, that's equivalent to not P because you never change your premise of your conditional. The first one listed, you never change that. You only change your conclusion. So the negation of not P implies Q would be not P and not Q. So I hope these examples help on your homework. The next thing we're going to talk about is De Morgan's laws, which tells you the negation of a conditional. So the negation of, not a conditional, sorry, the negation of a conjunction or the negation of a disjunction. Here we just talked about negations of conditionals, which is something different. The negation of a conjunction is you're going to distribute the negation to both parts and you flip the sign. So if you're talking about an and, you change an and, you change it to an or. If you have an or, you flip the sign down here. From an or, you change that to an and. So some examples. Let's say I'm negating not P and Q. Well, the negation would be not P, so that would be P, or not Q. Let's say I negate P or Q. That's going to be not P and not Q. So there's many more different variations of problems I can do here, but hopefully you understand that you distribute the negative and you flip the sign. This is different than a conditional. You see here we have a conditional. So if we're negating a conditional, it is always a conjunction. So the negation of a conditional is always a conjunction. What that means, it's always an and. And you never change the premise of the conditional. You never negate that. You only negate the conclusion. So let's look at some examples of things that will be similar to your homework problems. So it is Friday and I receive a paycheck. So we have the statement, it is Friday and I receive a paycheck. It's given by this, and we want to find the negation. So the negation of P and Q would be not P or not Q. So writing that out would be, it is not Friday or I did not receive my paycheck. So the negation of the statement, it's Friday and I receive my paycheck, would be, it is not Friday or I did not receive my paycheck. So these are examples from the homework. So you might have these exact problems or ones very similar to it. And again, I know this lecture is getting to be long, so just bear with me. Construct a truth table to determine the pairs of statements are equivalent. Now, truth tables are very long. It takes a lot of time to do truth tables. So instead of doing a truth table, you can get away with applying De Morgan's laws So let's look at, sorry, my pen is really touchy on me. So let's look at writing each one of these statements, 1, 2, 3, 4, in symbolic form. So sufficient tells me I keep the same order. So the sky not being clear. So let's say not clear. So the sky not being clear is sufficient for it to be raining. So not clear implies are. The sky being clear is sufficient for it not to be raining. So the sky being clear is sufficient for it not to be raining. So this would be C implies not are. The sky not being clear is necessary for it to be raining. So necessary is going to flip the order. So here I would have for it to be raining. So I'd have raining implies not clear. And the last one, necessary for it not to be raining. So not raining implies not clear. Sorry, implies clear. So here I have the sky not being clear sufficient for raining. So sufficient tells me the order is the same. So I have not clear implies are. Here sufficient means the same, and I have the sky being clear sufficient for it not to be raining. The sky not being clear is necessary. Necessary tells me I'm going to flip the order. So what's after necessary is actually the premise. So necessary for it to be raining, so are implies not clear. And then not to be raining implies the sky is clear. So actually I lied on this. You're not going to use De Morgan's laws. You're going to have to use a truth table. So you have to define your own truth table, and you only need C and R. So just like P and Q, you have C and R. So C is either true, true, false, false, and R is either true, false, true, false. So generally you'll be given this, but in the case, this is an example of a case where you're not given it, you have to make it up. Since you have two things, either being clear or raining, you have two squared rows. So it tells you need 4 rows. And from 4 rows, you put every possible combination. So true, 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 false, false, true, false, false. So there's 4 different combinations for C and R. So then you would need a not C, and you would need a not R, and then you would need the condition C implies R, sorry, not C implies R, C implies not R, and then you should be able, 2 of the columns are going to match up and the other 2 columns are going to match up, and then you can make a conclusions which one are equivalent. So sorry for misunderstanding the De Morgan's laws. Since they're all conditionals, you can't apply De Morgan's laws there, so you have to draw a truth table. So hopefully that gives you a start on that. This is a typical truth table you would see in your homework. I'm not going to necessarily do all of it, but let's look at R. Not R should be relatively easy to find, right? I look at R and I change the value of everything. So true would change to false, false would change to true. So false, true, false, true, false, true. So each one of them is straightforward. Then I look at P or R. So they have to both be false for them to be false. So if I'm looking at P and R, I'm going to look at these 2 columns for this row. So true, true would tell me true. True, false, that would be still true. True, true would be true. true false would be true, false true would be true, false false would be false, false true would be true, and false false would be false. So now I look at Q, and this would be an and, not R. So I look at Q and not R. Again, it helps with my fingers if I put my fingers right on those columns and trace it down. So here I have true and false, so that's false because I'm using the word and. So true and false would be false, true true would be true, false false would be false, false true would be false, true false would be false, true true would be true, false false would be false, and false true would be false. And then on the last one, you're looking at P or Q, so you're looking at this column and this last column, and you're adding them together with the conditional. So I can go through, see, this is false and this is false, so automatically these are true. I don't have to worry about the conclusion. So then I say true, the conditional's true, but the conclusion's false, that's false. So you can finish this in your homework. So this is a homework type problem. Hopefully that makes sense. They might ask you to come up with the negation of a statement. So not eating dessert is necessary for being on a diet. So necessary tells me I need to flip the order when I make this statement. So making the statement for being on a diet, so a person's on a diet, that's Q. Q is going to imply not P, not eating dessert. So knowing necessary and sufficient is important in this section. So necessary tells me that what comes after necessary is my conditional, and what comes before it is my conclusion. So now I need to find the negation. The negation would be the negation of P implies not, sorry, the negation of Q implies not P. Remember, we never negate our premise, so that's just Q implies P. So you're going to drop down and it's going to be Q implies P. Sorry, no. Not, remember, then we change this to and. So this would be Q and P. So this would be Q and P. So the person is on a diet and the person is eating dessert. So the answer would be the person is on a diet and the person's eating dessert. So the negation of the statement the person not eating dessert is necessary for being on a diet would be given here. So a lot of times it's easier to write the symbolic representation of the statement, negate it using the formula. You have to remember negating a conditional is always going to be an and statement, and you do not negate the premise of the conditional. You only negate the conclusion. Let's look at another one using sufficient in this case. So sufficient tells me the order's the same. So drinking caffeinated coffee, so that's represented by P. So drinking caffeinated coffee is sufficient for not sleeping, so not Q. So negating P implies not Q would be P and Q. So this is very similar to the previous one. So the negation of the statement in words would be the person is drinking caffeinated coffee and sleeping. So the person is drinking caffeinated coffee and sleeping. So I know this section is kind of long. Don't get too caught up with it. So your homework will give you feedback for being true or false. So they will let you know which ones are right. So if you do a truth table and miss one, you can just fix that one. You don't have to go back and do the whole truth table. So hopefully this helps. Some of it's a little crazy. This one's long, so just draw out that truth table. And sorry, mine's not very pretty, but hopefully a piece of paper, writing them out, keeping the lines aligned, it will make sense. Keep in mind, De Morgan's laws are only for conjunctions or disjunctions. For a conclusion, you have to remember the negation of a conditional. So this is a conditional, so this is only for conjunctions and disjunctions. The negation of a conditional is going to be never change the premise, and you change the conditional to a conjunction, so you make an and you make the negation of the conclusion. So let me know if you have any questions. You can post them in the Questions for Miss Van Ryan blog, and good luck.